An audience at 50 meters away from a singer on a stage is not satisfied with the performance of the singer. He threw his packet of drink and it hit the singer within 0.8 seconds after it is thrown. If the angle is 20 degrees from horizontal, calculate the magnitude of initial velocity of the packet drink, the magnitude of final velocity when it hits the singer, and the height of stage. Okay, first of all, we don't know what is the question talking about, yeah, unless we draw a picture. Yeah, we must draw a picture to represent the questions. Then only we can understand the situation happening. Yeah, so okay, anyway, I have drawn the picture to represent this. Okay, I drawn it over here. You see that? This is the one. Okay, so let us look carefully. Yeah, hope you can still see the questions. Okay, anyway, if you look at these question, he did says that the stage has a height. You see that the stage has a height. So that's why this one has a height. It has a height. Okay, it has a height. So this is the stage. Yeah, what we call this is the stage. And what we can say, this is the audience. This is the audience. And this is the singer on the stage. Okay, and this is the packet drink. Okay, the audience throw a packet drink on the singer. Maybe the singer sing lousy or lousily. Yeah. Okay, it hit the singer. Okay, so we can say the audience is 50 meters away from the singer. Okay, the audience is 50 meters away from the singer. It's not satisfied with the performance of the singer, so he threw the drink and the drink hit the singer after 0.8 seconds. So the time of flight of the drink is 0.8 seconds. Okay, now the angle is 20 degrees from horizontal. This 20 degrees. So what is the initial velocity of the packet drink? So we want to find u. We don't have the u. And also we want to find the, okay, let us first label. Okay, initial velocity means u. Okay, you find u, and then also find the final velocity, which is v. Okay, final velocity is this one. Yeah, this is the v. We need to find this v. Okay, it also has an angle. Yeah, we don't know what's the angle. Angle theta. We so need to find it. This theta is not the 20 degree. Yeah, this theta is for the initial velocity. Okay, so and then the height of the stage. Height of the stage we need to find sy. Later we need to find sy, the y displacement. Okay, now let us just use the, okay, we have all the information. Okay, the 50 meter is the sx. The 50 meter is sx. Okay, is x displacement. The height of stage is the y displacement. So now let us calculate. Let us find the initial velocity of the packet. Okay, how to do these questions? Right. First of all, we gather all the information into a table: x, y. Okay. We know. First of all, we know about the acceleration. Acceleration in x component is 0 because x is a constant velocity, and then y component is a free fall motion, so it's negative g. Okay, and then we also know about the okay, we need to find the initial velocity. Okay, so ux is equal to, okay, we need to find the initial velocity u, but we have the angle 20 degree, so we can say, okay, ux, this one ux is using cosine, yeah, but the uy is using sine because ux is adjacent to angle, uy is opposite to angle. That's why ux is cos, uy is sine. Okay, so we can write it like this. Ux is u cos 20 and uy is u sine 20. Okay, u sine 20. Now, Sx is equal to 50 meter, and Sy is that's the height. We need to find the height of stage. Okay, height of stage. And then what else do we have? We have the time taken. It's very useful. The time taken here. This is the t. This is the t. We need to find the t. Yeah. Just now this one is Sx. Okay, remember Sx. And the height is Sy. Yeah, we need to find. Okay, so the time taken is 0.8 seconds. This is the same for both components. This is the key. The time x is equal to time y, and the time taken is 0.8 seconds. So it's easy already, yeah, because we already have all the required information. Now let us find the first question. Let us find the magnitude of initial velocity, u. We need to find u. Okay, so initial velocity, yeah. Here, see the questions here. Okay, we need to find initial velocity. So how to find initial velocity? Do you think which component we choose to do the question A? Now question number 1. Okay. Question. Look at number 1. We need to find u. So A. Which one? We need to find u. Okay. I want you to look carefully. Which component has more information to find us the u? Is it x or is it y? If you look at x, we have A. We have u. We don't have. Yeah, we don't have the u. Displacement we have. Time we have. Oh, we have 3 information. Then of course can find the 4th information. But if the y component, it has g. We know it's 9.81. U we don't have. Sy also we don't have. The height of stage we also don't have. We have the time. So we only have 2 information. 2 information cannot get us the u. Okay? Because you have 2 unknown. We have the velocity and also the height. Okay. So so let us look at the x component. Okay, let us look at the x component. X component. So we use the x component to do it, yeah? Because x component has 3 information already, so we can find the 4th information. So we use formula s equal to ut plus half at square. S equal to ut plus half at square. So we know that acceleration is 0, ax 0. Okay, forget, you must put a subscript here. This is sx, ux, ax. Right now ax is 0. Okay, good. So we just left with s equal to ut. So s equal to ut, s is a 50 meter, and then u is a u cos 20, and then time taken is 0.8 seconds, 0.8. So what is u? What is the u? So let us calculate the u. Okay, so it's 19.95 meter per second. That's right. That's the velocity. Okay, that's the initial velocity. We got it already. So after that, we can also find. Now we can find ux, and later we can find uy also. Okay. We can find uy. Just use u sine 20. Okay. Now look at question 2. Okay, let us do the question 2. Find the final velocity when it hits the singer. Okay, if you look at the question 2, he says hit the singer, right? So hits the singer. So this one, yeah. So it hits the singer. So that is the final velocity, yeah. So we need to find v. For question 2, you need to find v. So just write here question 2. Find v. Right, find v. Okay. So let us find v. How to find v? V also has 2 components. If you look at this one, it has 2 components. It has 2 components. We need to find each one of them. We need to find Vx and also Vy. We need to find Vx, Vy. Then only we can find V by using Pythagoras theorem. Okay, so here we need to add one more component. Here we need to add one more component, which is v. So we need to find vx and also vy. So how to find? So let us look at the x component first. Look at the x component. V. Anyway, okay. This x component is a constant velocity. Yeah. The y component is freeform motion. You understand? Okay. Like you see, this x component is always constant velocity. So of course, the the vx is of course equal to ux, constant velocity. Okay. If you don't believe, we can just also use a formula. You know, v equal to u plus at. We have a lot of information here. We can just use a formula v equal to u plus at and show you how. V equal to u plus at. We know that all these are x component, okay, and then ax is 0. Yeah, ax 0. We see that. So vx is equal to ux. Vx is equal to ux. So let us calculate first. Vx equal to ux. So vx equal to us. That's why x component is a constant velocity. Okay. So okay, ux is u cos 20. So let's calculate u cos 20. Yeah, ux is u cos 20. So 19.95 cos 20. Okay, so what do you get? Yeah. So Vx is 18.7469. Yeah. We put more decimal place first because we want to make it more, more accurate. Now look at the y component. Look at the y component. Look at the y component. So y component, we need to find vy. Yeah, we need to find the vy. Yeah, this is the vy we need to find. So vy, what formula can we use? We have the a. We have u also. Yeah, because just use the u sine 20. We already have the u. Okay. Now also the time also we have. Okay, we can find v. So also we use the same formula, v equal to u plus at. V equal to u plus at. But this time all y component. All y component. So you just substitute. You just substitute all. You have uy is u sine 20. And then ay is negative g. You see that? Negative g. G itself is 9.81. Okay. Negative 9.81. This g itself, this is g is positive 9.81. The a itself is negative g. Negative g. So g substitute with 9.81. Got this. And then the time taken. So the time taken is 0.8 seconds. 0.8. So okay, so let's now u, the u just put inside. U 19.95 sine 20 minus 9.81, 0.8. So okay, so what's the answer? Okay, so what's the answer? Let's calculate. Let's calculate. I got it. Oh, negative value. I got negative. It's a negative 1.02447. 1.02477. So meter per second. So what does this tell you? What does this tell you? The velocity about the Vx and Vy? Positive Vx means what? Positive Vx means the velocity is going, because Vx is, x component is about horizontal component, y component is vertical component. So if Vx is positive, means it's going to the right. If Vy is negative, means it's going downward. It's going downward. So this is a positive and this is negative. You understand that? So in the resultant velocity is, we combine these two. Yeah, this one just copy and then yeah, yeah, and then the y component, yeah, this is the one. Understand? So this is the resultant. Yeah, this okay. So we got the resultant. After that, these two combine, and this is the resultant. This one, this is the v. Okay. Yeah. Just now this is the vx. This is the vy. Okay. Vx is positive. Vy is negative. So we have the v. We need to find angle theta. Okay. So find the Pythagoras theorem. Okay. Find the Pythagoras theorem. So you know, just take the vx square plus vy square, and after that you know how to do already. Yeah. So okay, just take 18.7469 square plus the vy also negative 1.0247 square. Okay, and calculate. Okay, so the answer is 18.77 meter per second. That's the velocity. Okay, the magnitude of final velocity. Yeah, which is you know, which is what velocity? This 18.77 is this velocity. Yeah, 18.77 is the final velocity here. 18.77 when it hit the singer. Okay. So now what's the, we need to find, you know, velocity is a vector. You must give both magnitude and direction. You cannot just give magnitude only. It's a vector. A vector, you must give magnitude and direction. So direction, you need to find the angle theta. So let's find out the angle theta. Okay. So angle theta is, let's find out. Yeah. Okay. So that's the angle theta we need to find. So this is the repetition of what we learned in chapter 1. Just take the y component, divide by the x component. Okay. So what do you get? You know, take the, you know, make it positive. The negative, make it positive. Modulus. Take this one, divide by this one. Okay. So what's the answer? So it is 3.13 degree. 3.13 degree. It is above or below? It's below the positive axis. It is below. You see, it is below. You must write below positive x axis. That's the direction below the positive axis. Okay, because vy is going bottom, going downward is negative. So the angle is below the positive axis. Yeah, it's like, you see, it's going below to hit the singer. Now, what is the height of the stage? Height of the stage also we find sy. We can do it over where? We can do it at number 3. We can do it over here. Yeah, number 3 can do it over here. So number 3 is we want to find height of stage, which is sy, and we need to find height of stage. How high is the stage from the ground? So sy, we need to find sy. So which is the y component, which is the y components. Okay, the y components. Okay, so how to find the y components? Okay, so right, how to find the height of the stage? So it seems that we have many information we can find. We can just use s equal to ut plus half at squared. S equal to ut plus half at squared. So it's all the y component. Okay. So sy is height. U is u sine 30. Time. Time taken. So let's find out. Yeah. So that is the h. Okay. U sine 20. U sine 20. U sine 20 is u 19.95. Okay. U sine 20 is 19.95. 19.95 sine 20, yeah, 19.95 sine 20. Okay, time taken 0.8, time taken 0.8 plus half a. The a is a negative g, isn't it? Negative g, negative 9.81, negative 9.81. G is 9.1, so time taken is 0.8 square. So sy is the h, we need to find height. So let's calculate. Okay, so the height of stage is is a positive 2.32 meter. So what it means by the positive sign here, the height of stage means is above the origin. It is above, is above the origin, above origin, or we can say the origin is the ground. Okay, the ground. So we can say this height of stage is positive 2.32 meter above. It throw from the ground. Throw from this is the ground. This is the ground. So the y displacement is 2.32 meter above the ground. So that's why it's positive. Okay, the stage is 2.32 meter above the ground. So that's the height of the stage. Okay, so that's it for this question. Okay, hope you enjoy. Read.